I'm going to talk about laser mechanisms of light emission for atomic system in thermal equilibrium with their surrounding. The emission of light is the result of absorption and subsequently spontaneous emission of energy. There is another process whereby the atom in an upper energy level can be triggered or stimulated in phase with an incoming photon. This process is stimulated emission. It is an important process for laser action. Therefore, three processes of light emission. One is absorption, second is spontaneous emission, third is stimulated emission. In absorption, there are two energy levels, E1 and E2. E1 is the highest energy level and E2 is the lowest energy level. Generally, atoms or electrons are in the ground state. For simplicity, we take only single atom in ground state. When the photon is incident on the ground state level, then this electron absorbs this photon and goes to higher energy state, that is E1, and this process is known as absorption. In spontaneous emission, atom is in the highest energy state, that is E1. This atom or electron jumps to the lower energy state and emit the energy in the form of light. In stimulated emission, atom or electron in higher energy state, this atom or electron absorbs another photon of energy difference E1 minus E2 and stimulate to jump to the lower energy state and emit the energy in the form of light. Background physics of laser. In 1917, Einstein predicted that under certain circumstances, a photon incident upon a material can generate a second photon of exactly the same energy, frequency, phase, polarization, direction of propagation. In other words, a coherent beam resulted. Interaction of radiation with matter means when external radiation is being incident on the medium, there are three processes occur simultaneously. One is absorption, second is spontaneous emission, and third is stimulated emission. In absorption, atom jumps to the higher energy state by absorbing the energy H. In spontaneous emission, atom jumps to the lower energy state by emitting the energy H. And in stimulated emission, and another photon is incident on the excited state and the atom or electron absorbs this photon and to stimulate itself and jumps to the ground state by emitting two photons. Absorption, spontaneous emission, and stimulated. This is the absorption, spontaneous emission, and stimulated emission. In stimulated emission, this is the process of stimulated emission when photon of energy h nu is incident on the lower energy state, then the atom or electron absorbs this photon and goes to or jumps to the excited state E2. And another photon stimulate this electron, then electron jumps to the lower energy state by emitting two photons. In absorption of light through a medium, light or photon must be absorbed in order for us to have a lasing action. Ix is equal to I naught exp minus alpha x. I naught, this is I naught, and this is Ix, and this is the system or active medium. Absorption, light that falls on a piece of material will decrease exponentially, that is alpha is equal to n1 minus n2 v21 hf n by c, where n1 is the number of electron or atoms in ground state and n2 is the number of atoms or electrons in the excited state. N1 is often more than N2, that is, N1 is less than N2. Example for tungsten, alpha is typically 10 to the power 6 per meter. If we want implication, alpha must be negative, that is, N2 is greater than N1. Population inversion. Population inversion is population inversion. Therefore, we must have a mechanism where N2 is greater than N1. Means the population of excited state must be greater than that of the lower energy state. This process is called population inversion. Population inversion can be created by introducing a so-called metastable center where electrons can build up to achieve a situation where more N2 than N. The process of attaining a population inversion is called pumping, and the objective is to obtain a non-thermal equilibrium. It is not possible to achieve population inversion with a two-state system. If the radiation flux is made very large, the probability of stimulated emission and absorption can be made for exceed the rate of spontaneous emission. But in two-state system, the best we can get is N1 is equal to N2. N1 is equal to N2 means in two-level system, population inversion is not achieved. To create population inversion, a three-state system is required. The system is pumped with radiation of energy E31, then atom in state 3 relax to state 2 non-ready to give. The electrons from E2 will now jump to E1 to give out radiation. This is the three-level system. First one is ground state, second one is metastable state, and last one is excited state. Generally, atoms or electrons are in the ground state. By the absorption process, these atoms or electrons go to uppermost level, means excited state, then goes to metastable state through non-radiative transition. In metastable state means E2 and another photon of energy E2 minus even given to this electron and this electron absorbs this photon and goes to or jumps to lower energy state by emitting the energy in the form of light. This transition is called lasing transition. Population inversion. There are two levels, E1 and E2. E1 is ground state and E2 is excited energy state. When the photon of energy h nu is incident on the system, then electron absorbs this photon and goes to higher energy state E2. E2 is the metastable state. The electrons are trapped in metastable state for 10 to the power minus 3 seconds. Another photon of energy E2 minus E1 trigger the electron to stimulate and go to the lower energy state by emitting the light of multiple photons. Means photon produced by stimulated emission have a definite phase relationship producing coherent light. When a sizable population of electrons resides in upper levels, this condition is called a population inversion, and it sets the stage for stimulated emission of multiple photons. This is the precondition for the light amplification which occurs in a laser, and since the emitted photons have a definite time and phase relation to each other, the light has a high degree of coherence. Optical feedback: the probability of photon producing a stimulated emission event can be increased by reflecting back through the medium several times. A device is normally fashioned in such a way that the two ends are made highly reflective. This is termed an oscillator cavity or Fabry-Perot cavity. Therefore, in a laser, there are two mirror. One is 100% reflecting and other is partially reflecting. This is the active medium or amplifying medium, and this is the output of laser. Three key elements in a laser pumping process prepares amplifying medium in suitable state. Optical power increases on each pass through amplifying medium. If a gain exceeds loss, device will oscillate, generating a coherent output. Thank you.